Hello. So, in this today's video lecture, we will discuss what is arithmetico geometric progression. So, mixture of AP and GP. So, it is also called as AP-GP, arithmetico geometric progressions. So, what is exactly the meaning of this? Consider AP here. The heading is arithmetico geometric progression. So it is, we can say it's an AP-GP here. It's called as AP-GP. Consider AP, say A. The next term is A plus D, A plus 2D. Like this, the last term is A plus N minus 1D. And the common ratio we take as R. If you multiply with this with R raised to 0, R, say A into R raised to 0, A plus D into R raised to 1, A plus 2D into R raised to 2, and so last will be A plus N minus 1D into R raised to N minus 1. So this type of the sequence, this is a mixture of arithmetic progression as well as there is a common ratio also exists. So this type of sequence is called as AP-GP, or it is called as the arithmetico geometric progression. So this type of sequence is called as the arithmetico geometric progression. So how to find the sum of AP-GP? That's the basic question asked. The question is how to find the sum of arithmetico geometric progression. So here, this type of sequence, example of this, examples say 1, 3, 5, 7, these are our normal arithmetic progression, and say as a 2 as a common ratio, so 2 raised to 0, 2 raised to 1, 2 raised to 2, so like this. So we can say 1 as it is 1 to 1 plus 3 into 2 plus 5 into 2 square, 7 into 2 cube. So this is called as AP-GP, arithmetic geometric series. The summation, the AP-GP summation. That is 1, 3, 5, 7 is in AP, and the multiple, the term which is always, this is in the common ratio there. This 2 is a common ratio. So this step to identify the AP-GP is very important. Once you identify, there is very much standard method to find the summation of n terms of AP-GP. So now we move to the next part, that is how to find the sum of n terms of AP-GP. So here, how to find sum of n terms of arithmetico geometric progression. So in this case, suppose how to find sum of n terms of AP-GP. Consider AP-GP having n number of terms as A, next A plus D into R, A plus 2D into R square, like this, A plus N minus 1D into R raised to N minus 1, like this. So this is your AP-GP with the n number of terms. So we will say as here, the sum. So first step is you have to multiply with the common ratio. The step number will multiply with common ratio. So what is the common ratio? That is R. So throughout you have to multiply with common ratio R into S. That means in this term you have to write here, that is AR. You start writing in this one. Next will be what? A plus D R square. So like this. What is this? The next here previous term of this is A plus n minus 2d into r raised to n minus 1, and one more term will come. That is a plus n minus 1d into r raised to n, like this. So one more term. Now we have to subtract. 2, 1 minus 2. This 1 minus 2 will give you s minus rs, that is 1 minus r into s. Here the first term as it is, which remain a only. If you take in this and this, if they are common, with a plus d minus a, so that becomes dr. So there is dr. The next term will be dr square. If you observe this, a plus 2d into this, you say dr square. So like this, there the last term will be dr n minus 1. If we subtracting this and this, we give a cancel. This is d r raised to n minus 1. But one more term will remain there. That is minus of a plus n minus 1d into r raised to n, like this. So, and this is nothing but, here we have to use GP formula for this. This is geometric progression. GP with n minus 1 term. So we have to use geometric progression formula and then divide by 1 minus r throughout, and that's the final answer for this. So that's very, very easy. We can say this a and this will get cancelled out. This is like this bracket and this bracket together, and then divide by 1 minus r, and then simplify this. After that, simplify this. This is the method to find n number of terms, the sum of n number of terms in APG. This is find the sum of n number of terms of APG. Now similarly, we will find sum of infinite terms in this, infinite terms. So here, how to find sum of infinite terms of ABGB. So remember that. So when it's come to the infinite terms, so infinite terms is only possible. Infinite terms, sum of infinite term exists only if mod of r is less than 1, because if mod of r is not less than 1, then sum of infinity will be infinity. So that is a very important concept. So in this case, suppose x is there, a plus b into r, a plus 2d into r square, like this, a plus n minus 1d into r raised to n minus 1. We will go with the same procedure, multiply with r. Here also the same. That is, here is a plus b r square. But we just ignore this, the last term. With the infinite series, there is no need to write the last term. Just subtract 1 minus rs is equal to a plus, that is dr square, dr cube, like this, up to infinity. So here we will use infinity formula for we will use, so answer will be what? 1 minus r into s, a plus, use the formula s infinity of gp. We use the formula of s infinity of gp, which is nothing but first term divided by 1 minus common ratio, that is a plus whatever the first term, 1 minus common ratio. So using this and then divide by 1 minus r, then find s. Finally you have to find s. So this is the method which you have to implement when there is a sum of infinite GPs or infinite terms of arithmetic geometric progression. When there is an infinite number of terms, we have to use this particular method. So remember that when the n term, both the methods are same, only the infinite series method is quite easy because you don't want to write the last term here. You just take this and directly we can approach and find the answer. That's it. Okay, so we will solve a few textbook questions and then few MCQs based on this. I think everybody should understand what is the meaning of arithmetical geometric progression. It's a mixture of AP as well as it's a common ratio exists. So we can say it's called as a APG. That is arithmetical geometric progression. General question is find the sum. That's it. So we'll continue with questions. Yes, so exercise 2.5 in the textbook. The sum is this. Question first, 2 plus 4x plus 6x squared plus 8x cubed up to n terms. You can observe this properly. What we can say, 2, 4, 6, 8. This is in 8. If you observe this, the x is to 0 here, x is to 1, x is to 2. So this is in GP. So this becomes APGP. What is this? It is a arithmetic geometric progression mixture. So what is Tn? First of all, you have to find Tn in this case. You have to find Tn. So Tn of AP is, what is the Tn of AP here? It is a plus n minus 1 into t. So a is 2 plus n minus 1 into 2. So 2 plus 2n minus 2. So it is 2n. Tn of GP. Tn of GP is access to 0 straight away, the first term. Because a r raised to n minus 1. It is a r n minus 1. So a is the first term, it is access to 0. R is x sub is x. So it is x plus to n minus 1. Therefore, Tn of APGP is equals to what? What is Tn of APGP here? It is 2n x is to n minus 1. So that is a Tn of APGP is there. Therefore, we can write s is equal to 2 plus 4x plus 6x squared plus 2n x is to n minus 1 like this. And then you have to form the method. The method is you have to multiply s with the common ratio. So we multiply the common ratio, that is n. So multiply by n. So x into s. We will not write the first term, we will write here, that is 2x. Next it is 4x squared. And so on. So here, one before the term will be 2n minus 2, x is to n minus 1. The next term will be 2n, x is to n, like this. It is 2n, x is to n. And then subtracting this two. The subtracting, this is number 1. This is number 2. So, as per rule, let's just follow the rule. That is 1 minus 2. So, it is 1 minus x into x. So, that is 2 plus 2x, 2x squared, 2x cubed, and so on up to 2x raised to n minus 1. And the last is minus 2n x raised to n, like this. That is the thing. Now this and this we can take together. So it is 2 minus 2n x raised to n, like this. This is one bracket. And what about this? It is G, geometric progression with n minus 1 term. This is the n minus 1 term where the x is a common ratio. So therefore it is plus a, that is 2x, a into 1 minus r raised to n. Yeah. So 1 minus x raised to n minus 1 upon 1 minus x, because there is a n minus 1 term. So a is first term, so first term is 2x, x is the common ratio, and n minus 1 terms are there in this. So finally, look at that. So what is the answer for this is, if it s is equals to, because it's 2 common if required, because 2 is taken common, it is 1 minus nxn upon 1 minus x. And here it is 2x, 1 minus x plus 2n minus 1 upon 1 minus x squared. So like this. So that is the sum of n terms in this ABGB. That is the answer for this. That's very easy because we divided 1 minus x here. So that is the answer. I think everybody understood this one. Right? Okay. Yes, 2.5, the next question, question number 3. So 1 as it is, the x is 2 into 2, 3 into 4, 4 into 8, 5 into 16. The question is find the sum of n terms. Now, clear that here. First, if you observe the first term, 1, 2, 3, 4. So that is 1, 2, 3, 4, 5 in arithmetic progression. The next number is say 2 raised to 0, 2 raised to 1, 2 square, 2 cube. That is 2 raised to 0, 2 raised to 1, 2 square, 2 cube in geometric progression. So it is the given ABGB is given sequences ABGB form, that is arithmetic, arithmetical geometric progression. This is ABGB, and that is nothing but 1 into 2 raised to 0 plus 2 into 2 raised to 1 plus 3 into 2 square plus 4 into 2 cube and so on, like this. So it is like this. So what is the Tn for this? We find Tn of AP. So Tn of AP here is very simple. It is n only because it's 1 plus 2 plus is simply n. And Tn of GP is, what is GP is 1 less. 2 raised to 1, first term is 0. So n term will be 2 raised to n minus 1. So Tn of APGP will be what? N into 2 raised to n minus 1. Therefore, the sum of the required APGP will be S is equal to 1 into 2 raised to 0, 2 into 2 raised to 1, 3 into 2 square plus nth term, that is n into 2 raised to n minus 1. Now, you just follow the method. The method is you have to multiply with the common ratio. So what is the common ratio here? The common ratio is 2. So multiply by 2. So it is 2s. And we will not write here, we will write here. So it is simply 2. It is 2. The next will be 2 into 2 square. Like that. Here it will be 1 less, which is n minus 1, 2 raised to n minus 1, n 2 raised to n, like this. So it is approaches like this. Then subtracting this. Then subtracting, that is 1 minus 2. This is say 1, this is say equation 2. So 1 minus 2, s minus 2s will give you simply minus s. So first term is as it is, which is 1. The next term is 2, this 4 minus this, so that is 2. It is 2 raised to 1. This is t minus 2. is 1 is 2 square, 2 cube, that is up to 2 raised to n minus 1. And this minus n 2 raised to n. So it's like this. Now, these are nothing but, so this and this we get together. So there's a 1 minus n 2 raised to n, and this is the sum of n minus 1 terms of geometric progression, where the first term is 2 and the common ratio also 2. So it is 2 into 2 r raised to n minus 1 upon like this. Sorry, it should be n minus 1. 2 raised to n minus 1. So the final answer will be what? Is 1 minus n into 2 raised to n. This is 2 minus 1 is this. 2 multiplied in, that gives you 2 raised to n minus 2. So that is the minus s. So it is 1 minus 2 will give you the minus 1. So it is n into 2 raised to n plus 2 raised to n, and this is minus 1. So final s will be n into 2 raised to n minus 2 raised to n plus 1. So 2 raised to n, if you want it common, that's the final answer for this. So s is equal to n into 2 raised to n minus 2 raised to n plus 1. n into 2 raised to n minus 2 raised to n plus 1. Yes, so next question of the infinite series is so 1, 2 by 4, 3 by 16, 4 upon 64. I already told you that the sum of the infinite series exists if the ratio should be less than 1. The common ratio, that is ABGP, the common ratio of the ABGP should be less than 1, because if it is greater than 1, it is automatically the nth term is already infinite. Sum is infinity. So it should be reduced. When this reduction is possible, when the r is less than 1. So here, if we observe it in this particular question, 1, 2, 3, 1, 2, 3, 4, like this, it is in AP. It is in AP, and this, the first term, say 4 raised to 0. Because 1 upon 4 raised to 0, so that's not a problem. The second term is 1 upon 4 raised to 1. The next term is 1 upon this, 1 upon 4 cube, and so on. So common ratio here is, common ratio is 1 upon 4. So which is less than 1. Therefore, sum of infinite series is possible. So sum of infinite series in this is equals to 1 plus 2 by 4 plus 3 by 16 plus 4 by 64, like this to infinity. So when its infinity is there, the method is saying that is s infinity multiplied with the common ratio, that is, you will not write here, so it is 1 upon 4, then it's 2 upon 16, then it is 3 upon 64, like this. And then this is number 1, this is number 2. So 1 minus 2, that is 1 minus 1 by 4, 1 minus 1 upon 4 into s infinity. Here the 1 is as it is, plus 2 minus 1. Which is a 1 by 4. The next is 1 upon 16. Next is 1 upon 64, and this is infinite series. So this is we have to use sum of infinity for geometric progression. The sum of infinity for the geometric progression is a upon 1 minus this. Then the formula s infinity is a upon 1 minus r. We use this formula here. So therefore 1 by 4, that gives you, and this is what? 4 minus 1. So it is 3 upon 4 into s infinity, like this. So here it is 1 plus 1 by 4, 3 by 4. 4 cancel, so it is a 1 upon 3. 1 plus 1 upon 3. So that is 3 plus 1, that becomes 4 upon 3. That is 3 plus 1 is 4 upon 3. And this is 3 upon 4. So that becomes 16 upon 9. So here, therefore, S infinity will be what? 4 upon 3 into 4 upon 3, which is 16 upon 9. 16 upon 9, that is the answer of this. So answer for S infinity here will be what? 16 upon 9. Yes, one more question, that is question number 2, cut third. Here the question is 1 minus 4 by 3, 7 by 9 minus 10 upon 27. What is the sum of infinite series here? If you observe this, there is an alternate plus minus is there. So whenever there is an alternate plus minus in GP, you have to give the plus minus sign to GP, not AP. So here, if you observe that 1, 4, 7, 10 in AP. So that don't give plus minus sign to the AP, because AP there should be the common difference. So it's always either the same sign, positive or smaller value. So here, this is there. But if we observe this term, so it is, we can say 1 upon 3 raised to 0. The next term is minus 1 upon 3 raised to 1. The next term is 1 upon 3 square. Then minus 1 upon 3 cube. And so on. In geometric progression, the common ratio has minus 1 upon 3. So here the common ratio is minus 1 upon 3, and therefore the sum of infinite series in this, that is 1 minus 4 by 3 plus 7 upon 9 minus 10 upon 27, like this. You have to apply the same method, you have to multiply with the common ratio. So common ratio here is minus 1 upon 3 S infinity. So we'll write this here, minus 1 upon 3, this becomes plus, so 4 upon 9, then this becomes minus 7 upon 27, and so on, like this. So this is number 1 and this is number 2, and then 1 minus 2. So 1 minus 2 will give you 1 plus 1 upon 3 as infinity. 1 is as it is. Here minus 4 plus 1 by 3. So minus 4 by 3 plus 1 by 3 is minus 3 by 3. So it is minus 3 upon 3. The next is 7 minus 4, which is 3 upon 9. So there is 3 upon 9. Then minus 3 upon 27. So it is like this. So if you take this 3 as common here, 1 minus 3 as a common, so 1 minus 3 as a common, so this becomes 1 upon 3, then minus 1 upon 9 plus 1 upon 27 minus like this. So that is there. So we take minus 3 common. So this is nothing but 1 minus 3. This is the sum of, again, infinite with 1 upon 3 as a common ratio. Minus 1 upon 3 is a common ratio. The method is same. So it is a upon, so a is 1 upon 3, 1 minus 1 upon 3 as a common ratio here, and this is 3 plus 1, that is 4 upon 3 S, so it is 4 upon 3 into S, so this is 4 by 3 S is equal to 1 minus 3 1 upon 3, that is 3 plus 1, so it is 4 upon 3. 3 cancel, so that is 3 by 4. So finally it will be 4 upon 3s is equals to 1 minus 3 cancel, so it is 3 by 4. 4 minus 3, that is 1 upon 4. So 1 upon 4, 4 upon 3s, so therefore x is equal to 1 upon 4, 3 by 4, so it is 3 by 16. So that is sum of infinite terms. His answer is 3 upon 16 for this particular question. I think everybody understood this one. The method is the same. For infinite series, it's quite easy. That's it. Yes, so now we will discuss the MCQs here. MCQs for J point of view. So the question number 35 is about JW MCQs. What we discussed till now. 1 plus 4 by 5 plus 7 upon 5 square plus 10 upon 5 infinite series. So again it's very simple. See here, there is 1, 4, 7, 10 in AP, that is clear. This is the first one is 1 upon 5 raised to 0, 1 upon 5 raised to 1, 1 upon 5 square in geometric progression. R is 1 upon 5. So what is the S infinity in this? S infinity is 1 plus 4 upon 5 plus 7 upon 5 square plus 10 upon 5 cube as it is. The next is multiply this with 1 upon 5. So 1 upon 5 into x infinity. We will not write 1 here, we will write 1 upon 5. Next we will write here 4 upon 5 square. Next we will write here 7 upon 5 cube and so on. That is, and then 1 minus 2. So this is 1 minus 1 upon 5. 1 minus 1 upon 5 s infinity. That is equal to 1. 4 minus 1, so it is 3 upon 5. Next, that is 3 upon 5 square, 3 upon 5 cube, and up to infinity is there. So, this 1 plus 3 common, 3 second is common. The 1 by 5 is the first term. So, 1 upon 5, 1 minus 1 upon 5, that is a upon 1 minus r for s infinity. So, using this formula, 3 second common. The common ratio is, first term is 1 by 5, common ratio is also 1 by 5. So 1 by 5, A as well as R also 1 by 5. Here it is 1 minus 1, so it is 4 by 5 S infinity. So it's 1 plus 3 into 1 upon 5, 4 upon 5, 5 by cancel, it is 3 by 4. So 1 plus 3 by 4, which is 4 plus, that is 4 plus 3, so it is 7 upon 4. So 4 by 5 S infinity. So S infinity will be what? 7 upon 4 into 5 upon 4, which is 35 upon 16. So answer for this is 35 by 16. So I think it's very simple one. Just you should know what is it is APGP, and you have to just follow the method for APGP. That's it. Yes. So next question, question number 36. 1 plus 2x plus 3x squared plus 4x cubed up to infinite is given as mod of x as 1. So mod of x is given as 1, that means infinite series exists because common ratio is less than 1. So it exists. So now s infinity, now I'm doing directly because s infinity is 1 plus 2x plus 3x squared plus 4x cubed and so on. So x is a common ratio, so multiply with x. So x into infinity will not write this. Here is x, next 2x square, the next is 3x cube, and so on. Then subtracting this, so it is 1 minus x into s infinity, 1 as it is x This is x square, this is x cube, and so on. So this is the sum of infinite series, which is x upon 1 minus x, because x is the first term, and that's the common ratio. So this is the formula which we applied here, a s infinity. So that is the formula. So here in this case, up to this, x upon 1 minus x, because x is the first term, x is the common ratio. Now let's just multiply this. So it is 1 minus x and s infinity, 1 minus x plus x upon 1 minus x. X is cancelled. Therefore, s infinity is. So that's it. That's very simple one. That is a question number 36. Answer 1 upon 1 minus x the whole square. Yes, so next question number 37 here. So 37 is 1 plus 3 plus 7 plus 15 plus 31 up to n terms, and the options are given to you. So now in this, why I have written the options here? Because we are not going to solve it by conventional method, because it is not easily observed that it's ABCD. It's not ABCD form. It's a random sequence. And when the random sequence and the options are also given, it is better to go in the option method. So what is option method? We consider n as 3. We say n is equal to 3. If n is equal to 3, you add first 3 terms. Add first 3 terms. So what is that? 1 plus 3 plus 7, that is equal to 11. 1 plus 3 plus 7 is equal to 11. Now we put in option number 1, in option 1, put n is equal to 3. Put n equal to 3 in the first option, that gives you 2, 3 plus 1 minus 3. So that is 2 raised to 4, which is 16 minus 3. So it is 13, which is not matching, so this is the wrong option. Next, option number 2. Option number 2. It is this, that is 2 raised to n plus 1 minus n minus 2. So here, if you put n is equal to 3 in this, it becomes 2, 3 plus 1 minus 3 minus 2. So that is 2 raised to 4, which is 16 minus 3 minus 2. That becomes 16 minus 5, which is 11. So it's matched with this. So option 2 is the correct answer. So the correct answer is option 2. For our other side, we can put the n equal to 3 in this. What will happen? 2 cube, which is 8. 8 minus 3. And this becomes 3. So not. So option 2 is the correct. You can check it by taking first 4 term also. If you have doubt because of none of this, take n equal to 4. N equal to 4 means you have to add 4 term and then you have to check. So it is like this. It's very simple one. So you can proceed with this type. Whenever there is a random, we cannot say it is an ABJD. It is a random sequence is given. The sum is given and options are also available. We can go by this method. That is very easy method. Here, if there is 2 matching options, we can take n equal to 4, n equal to 5, like that. The first you can add first 4 term, you can add first 5 term and put n equal to 4 or 5 in the given option and check what is matching here. So that's, I think it's very easy method, right? Yes, the next quite similar question, question number 38, same as that of 37. That is 2 plus 4 plus 7 plus 11 plus 16, and terms and options are available. We cannot say it is ABGB, so again we go with our method, that is put n is equal to 3. So put n equal to 3. So addition of first 3 term, 2 plus 4 plus 7, that is equal to 13. 13. And now options. So option 1. So option 1. 1 upon 6. 3 square plus 3 into 3 plus 8. So what is this? It is a 9 plus 9. 9 plus 9, 18. 18 plus 8, 26. So it is 26 upon 3. which is 26 upon 6, which is not correct because we give you 13 upon 3. Option 2. So option number 2 here, n by 6. So n by 6, n is 3. So it's 3 by 6. The middle value is n, so it is 3 square plus 3 into 3 plus 8. So that is again 26. So 1 upon 2, 9 plus 9, 18 plus 8, 26. So 26 upon 2. 26 upon 2, which is 13, so it is correct. If you have doubts in the option 3, we can check for option 3 as well. Option 3, 1 upon 6, 3 square minus 3 into 3 plus 8. So 9 minus 9 is out, so it is 8 upon 6. And option 4, again this middle value will be 8, and that is, so option 4 is no doubt. Option 4 is also wrong because this would be 3 by 6 and the middle value will be 8. So it is 8 by 2, which is 4, which is again wrong. So correct answer is only this. So that is the option 2. So here the option 2 is the correct answer. Option 2 satisfies this. That is, the sum of first 3 terms is 30. We put n equal to 3 in this, and that becomes 26 upon 1 upon 2, and that gives you 13 as well. This is a very easy method, isn't it?